Hey guys, welcome back to my channel. So today let's draw some structural formulas from the compound, so from the name. So this we have 4-chloro, 5-methyl, 2-hexanol. I like to start with the main part of the compound to the right. So we see that's a hex here, so that means we have 6 carbons. You can draw it out, leave a little bit of space for your hydrogens or your substituents. We have an OL, that means we got an OH we have to put somewhere. And it goes on the 2 carbon. And I have a habit of numbering from right to left, whereas this is my 1 carbon, this is my 2 carbon, and so forth. And we can go ahead and just kind of check that off as we go along. On the 5 carbon, we have a methyl. That's the 5 carbon. A methyl is expressed CH3. We go ahead and check that off. And on the 4 carbon, we have a chloro designated Cl. All you have to do from here is fill in your hydrogens. CH2, CH, CH, CH3. All right, so there you have it. You can also do this from left to right as well. So let's go ahead and just do that. So if we drew our carbons out like this, I can do this as my 1, this is 2, this is my 3, this is my 4, 5, and 6, and so forth. Alright, so on the 2nd carbon, we'll have the OH. On the 4th carbon, we'll have the Cl. And on the 5th carbon, we'll have the methyl. And you can go ahead and just fill in that like this. Fill in your hydrogens. Right? So whether you go from right to left this way or left to right this way, this compound is symmetrical. So if you turn this thing all the way around this way, it'll look like one or the other. So either way you want to go is okay in that regard. So, and again, if your professor has something specifically he or she wants done, do whatever they say do. But in general, the stuff's symmetrical, so you don't have to worry about which direction that you start from. Now the question may arise why to draw this methyl group up here instead of down here by this chloro group. And that is due to something called steric hindrance. Steric hindrance is when you have a molecule, such as all these hydrogens here, that are bumping into this adjacent chloro group. So what happens is you're more than likely to see this in nature, because these hydrogens around this carbon have a lot of room to spread around up here, where you have less steric hindrance than you would on the bottom, where you have more steric hindrance bumping into these adjacent functional groups. So how would you write the structural formula for this compound? So what I do is look at the right of this compound. I see a bute, it's an alcohol, and it's a cyclo. So bute means it's 4 carbons. The OL means it's going to have some type of OH group, an alcohol group. And cyclo means we're going to have some type of ring compound. So how do you draw a 4-carbon ring compound? So you got 1, 2, 3, 4, like that. So 1, 2, 3, 4 carbons. So each one of these corners represents a carbon. So that's your ring for any type of butane or cyclobutane, or in this case butanol. And since we have trans here, and this also can be cis, we have to show the stereochemistry. What the stereochemistry means is we see this as a 2-dimensional plane, but in reality it's 3-dimensional. So how do we represent that and articulate that in our drawings of what side of this molecule that the alcohol is on versus the ethanol here? So we represent that by drawing a wedge like this, and we put the alcohol group on that. Now, when you see the wedge that's filled in, that means that this alcohol group is closest to you from the perspective of you looking on your paper, on your tablet. And when you see it represented like this here, in these little lines, this represents that the functional group is furthest away from you. So these are not on the same plane. And this is an ethanol. So we get this from this ethanol. Ethanol is CH3, or rather CH3. And this would be trans. What you do is just break this down. This is going to be your primary functional group. Here you just kind of draw that. And you have this ethyl as well. That's on this 2 carbon. So you can start numbering here. 1, 2, 3, 4. Now I could have just as easily, named this the one carbon or this the 1 carbon, because this is symmetrical, and so you can kind of draw it differently. As long as you put the alcohol group on the 1 carbon and establish that as the 1 carbon, that's all that matters. And of course, from there you have your 2 carbon, which is going to contain this ethyl group. So again, this filled in wedge here means that this functional group is closest to you. When you have these lines, that means that the functional group is further away from you. Now that means that it's across from each other. And when it's across from each other, so in other words, if you kind of drew a line from here to here, this would be front to back, right? Or back to front. That means that you got to cross over the compound to get to the other side, hence trans, right? Cis would mean if either this compound or this compound had both the solid wedge or the line wedge, that would be how you would represent a cis. And just to show you how you can do this both ways, you can see up here we have it, the OH, like this. And we could have easily done it like this as well. So I could have put the ethyl group here, and I could have put the OH here, and that's still a trans because it's on the opposite side. Now, how would a cis look? Would look like this. We can just fill this in, fill that in to make it look like that one, and now we have a cis. Or we can do them both like this. You get the idea, and that would be a cis. And what this would mean is both of these compounds are on the other side of this other side of this square. Anyway, hope that helps. Okay, so what I've done is taken this compound that we were working with and made a model out of it. So we can see the OH group here at the top, and we can see this ethyl group at the bottom. And it's kind of hard to see the ethyl group in this one, but this is the first and that's the second carbon, just like this is the first and second carbon. But what I want you to see is if we drew a plane right down the middle of this. So I've taken this and kind of made it left, turn it to the left, so we can see a three-dimensional kind of view of this. So I've taken this here and turned it to the left, so where this OH is kind of out front and this methyl group is over on this side of it. And you can see clearly that this alcohol group is on this side and this ethyl group is on this side. So it's on the opposite side of this plane, meaning we have the trans conformation on this. Okay. So the inverse of that is we have the cis. So we drew a line down this plane. We can see that this ethyl group and this alcohol group are both on the same side, meaning it's cis. So they're each on this side. So they're not over here. They're in the same plane, same side, cis. And it doesn't matter. I kind of flipped the alcohol and the ethyl group. But the same idea applies either way. If you have the solid wedge, it's going to be a cis configuration. If you have this little line wedge here, it's going to be a trans configuration.
Anyway, hope that helps.
All right, so how would you write the structural formula for this compound? So we see that we have a prop, so we know that's going to be 3 carbons. We see an OL, so that means we're going to have an OH group, which means it's an alcohol. Now we have bromo, tribromo, so that means we're going to have these bromo groups, or bromide groups, 3 times. So we're going to have 3 of these on our 3 carbon compound. So let's kind of just piece it together. So go ahead and draw your 3 carbons like this. And again, I have a habit of going 1, 2, 3 on these for some reason, but you can name this the first carbon, that the 3rd carbon as well. So however you want to do that works. So I'm going to go right to left. So I'm going to put this as I like to go ahead and work with the functional group that names the compound. So we have this OL here. That means on the number 2 carbon, which this would be the 2nd carbon, where no matter where you count it from here or here, that's going to be the 2nd carbon. We're going to have the OH group. So go ahead and put that there. Now we can kind of check that off. We can kind of check that off. We already have our 3 carbons, so we can kind of check this off. So let's work with these bromide groups here. So we see from this we have 1, 1, 2. That means we have 2 bromo groups on the 1st carbon. And I guess I'll just draw it like this to keep from confusing anyone. So we're going to have bromo. And what you can do is just put a subscript 2 on there to indicate that you have 2 of these on the 1st carbon. So that's all this means. You got 1, 2 on the first carbon. You also have 1 on the 2nd carbon. So it'll look like that. And then you just do CH3 there. So that's one way of doing it. And remember, we don't have no carbons on this, no hydrogens on this middle carbon because it already has 4 bonds. Another way you can express that is going from right to left. This will still be an OH here. You'll still have your bromo group here, but you can also put it over there as well. And whereas this is the 1st carbon, this is the 2nd carbon, this is the 3rd carbon. Up here, this was the 1st carbon, this was the 2nd carbon, this was the 3rd carbon. So you can go either way because these molecules are symmetrical. You can also express this like this here, right?
So you can kind of play around with this and practice and know that that subscript means that you have 2 of those groups on that 1 carbon. That way you don't make those little mistakes on a test. All right, so if you got any questions, just leave them in the comments and I'll get back to them as soon as possible. Also, like and subscribe if you like this content. See you on the next one.